Alright, so this is the abbreviated 3.4 notes. And what you're going to do in this section is essentially take the 6 parent graphs, the parabola, the cubic, the square root, etc., and you're going to be able to reflect them. So over the y-axis, over the x-axis, move them around, left and right, up and down, and then also stretch them out, or maybe even compress or squish the graph in the x or in the y direction. And so basically in that order, that's what you want to do. So the first thing you're going to do, if there are any, is reflect, okay? And that is one of two things. You'll have the parent graph, whatever f is, maybe it's x squared, with a minus sign in front of it, okay? That will reflect over the x-axis. If you have a negative inside of the parent graph, that will reflect over the y-axis. All right, and then next, if there are any, you're going to want to do any stretching or compressing. And what that typically looks like, you'll have a number in front of the parent graph, or maybe in front of the x within the parent graph, so something like this. Okay? And in either of those cases, in this case, if there's a number in front of the function, a good way to remember this is that since this technically represents y, that means that all the y coordinates, so the y coordinates get multiplied by whatever a is. Okay? And this one, if you have a number in front of the x, it's going to affect the x coordinate, but it's actually going to do the opposite, kind of like when we do left and right movement. You know, if you see a minus sign in the parentheses, you go right. Kind of do the opposite. It's the same thing here. So if there's a number in front of the x, what you're going to do is take the x coordinate and do the opposite to it. So you're going to take the x coordinate and divide by whatever that a value is. Okay, and then the last thing that we'll do is the translations. And those are one of several. You can have f of x minus a number, f of x plus, f of x, and then outside of the parent graph, plus or minus. Okay, and in all of these cases, we're going to get just the entire picture to shift. Nothing's going to change about the shape. It's just going to like move. So here we go right, C. In this case, we go left. Here we're going to go up, C. And here we go down, C. Okay, so these are the transformations that you're going to see. And I'll just do a couple of quick examples to kind of illustrate how these work. Again, most of these should be somewhat familiar to you. Maybe not so much with the stretching and compressing, but I know that you guys have shifted graphs before and flipped them around and things like that. So the one thing I do want to emphasize, though, is that you should always, oops, can't spell, factor any negatives or coefficients in front of x. For example, let's say you had the parent, or you had the graph the square root of negative x plus 3. Okay? So let's just do this one as a quick example. What you want to do, anytime there's a negative sign in front of the x or a number, like if we had a 2 or a 3 or a 4, you're going to want to factor it out. So, factor out the negative sign, so now the x becomes positive and the 3 becomes a minus 3. And the reason we do that is because now you actually see which direction you're moving. Okay, up here it might look like we're going to shift to the left 3, but what ends up being is actually a shift to the right 3. Okay, and so let's actually graph this so you can see what it looks like. Parent graph, which you should already know, is just y equals the square root of x. So what I would recommend doing is just starting with that. So 0, 0, 1, 1, 4, 2. Here's the parent graph. Okay? And now we're going to write down what is going on with this graph. So first, kind of squeeze up here. We always want to reflect first if there's any reflections, and then stretch or compress, and then do our left, right, up, down. Since there's a negative inside in front of the x, inside means we're going to reflect over the y-axis. Okay? So let's do that step next. So now these points are going to go across the y-axis, and so we have this point goes right over here. 0, 0 is going to stay because it's on the y-axis, but this point that was at 4 on the x-axis is now going to go across the y-axis and go to negative 4. And so now we have this. So no longer are we looking at the original graph, we're just looking at this new one. So this is after I do first step, okay? Second step, let's do that one in red. I've reflected, so that's good. And now the only other thing left is that we have a translation. In this case, we're going to go right 3. And so all we're going to do is take our entire picture and just move it right 3 units. So this is going to go 3 units to the right, so is that point, and so is that point. And so now we get this. Oh, kind of missed that point there. Let's try again. That's better. Okay, so this red one is after I've done the second step, and in this case, that's my final graph. Okay? So when you're doing these, you can either label, it is helpful to write out what steps you're going to take. It could get kind of convoluted though if you have 3 or 4 different things going on. So it might be a good idea to kind of do these in pencil, and then as you take parent graph and do something to it, draw the new one, erase the old one, do the next step, repeat the process. So in the end, now we just have the final graph, which is this one here. Okay? Now let's try another example. And by the way, this technique works, so I'm going to do another similar problem to this one, but if I gave you a picture with a graph, okay, so actually I can kind of go back here and add, so let's say for this last example, let's say I gave you a picture instead. And we had something that looked like this. So this was f of x. so maybe you get a weird looking picture that represents f, and now I might want you to graph y equals negative f of 2x plus, I don't know, 1, something like that. Okay, so if you see something like this, you're going to treat this shape, not the square root or any of the other ones, but it doesn't matter how you start or what it looks like, all the rules apply. Okay, so I'm not going to finish this one, but we will write down the rules. Okay, so first we reflect if possible, and there is a reflection over the x-axis. So this will just now get flipped. You know what, actually I will do this, this is a good problem. So let's reflect over x. And then the second step is going to be, since there is a coefficient in front of the x, that's kind of a stretch or a compression. Since we're multiplying by 2, we're going to take the x coordinates divided by 2. And then the last thing we'll do is actually go up 1. Okay, so let's see what that looks like. So if we reflect over x, this is going to stay put. This point is going to go down to -1. This point is going to go down to -1 as well. And so now here's the new graph. I'm going to erase the old one. Okay. So step 1 is done. Now we want to take the x coordinates and divide them by 2. So it might be helpful to write out, the coordinates for the points. Here we have -2, 0. Here the coordinates are -1, -1. Here the coordinates are 2, -1. And so what's going to happen is these coordinates are going to have the x's divided by 2. And so now we get these points. -2 becomes -1, 0. This point, -1, -1, becomes -1/2, -1. And then this point, 2 divided by 2 is 1. The y's always stay the same when you're doing an x division or multiplication. And so now, I'm just going to draw these points. And so now we are -1, 0, -1/2, -1, so somewhere about here, and then 1, -1. And then when you connect, you're going to see that it looks pretty much like the same shape, but now it's been compressed in the x direction. So that's the second step. All right, and now the final step is to just take these points and shift them all up 1 unit. So this point goes up 1, this point goes up 1, this point goes up 1. And so now the final graph is going to look something like that. Okay, I am kind of out of time, so I think this will be the last example, but I think the rest is just you guys practicing. I was going to do a different one, but I don't have time, I'm sorry. So hopefully this is enough to get you going with 3.4.